In this video, I will demonstrate the link between histograms from the descriptive statistics chapters and the probability density function, or PDF, from the continuous distribution functions. In particular, the PDF graph for the normal distribution is important, as it will be used often later on in the semester or the course. In this Excel spreadsheet, I have some data that I made up. I have a variable here called XXX, and I have some values that I just made up and typed in. And as I did in a previous video, I defined bins 0 to 1.99, 2 to 3.99, 4 to 5.99, 6 to approximately 8, and 8 to 10. And then in this column, frequency, I have the counts, or the number of times that each of those ranges were hit in the data. So in that column A, the variable XXX, I had values of 0 or 1 twice. 2s and 3s, I had 4 of them. I had 5 4s or 5s, 3 6s or 7s, and 1 8 or 9. And I guess it was the value 9 right there. So then I had Excel create a I think I call it a column graph or a bar chart. I think it was a column graph is what Excel calls it. And that creates a histogram right here. Remember the important difference between a histogram and any other type of bar chart or column chart, and that is that a histogram specifically shows frequency on the y-axis. So these are all of our values, or those frequencies, the counts, the 2, the 4, the 5, the 3, and the 1. And then we've got our bins down here on the x-axis horizontally. Now, the PDF diagrams in the continuous distribution chapter always show probabilities or decimal places along this y-axis. And we can do that with a histogram too, this plot like this, by simply asking, instead of how many times did values occur between 0 and 1.99, but what proportion of the data points took a value between 0 and 1.99. And we can add up all these values here, all these counts, and there are 15 total values. Or we could just count the number of data points here, and you might remember there's a function in Excel called count. Because there are 15, we could calculate the percentage of values that are between 0 and 1.99 simply by taking these frequencies and dividing each by 15. And instead of typing in 2, we could simply refer to the value in this cell. And the nice feature of that is that we can take this formula and copy it down. And now Excel has calculated that value divided by 15, this value divided by 15, all the way down to this value divided by 15. Now if we have Excel change this column graph, or this histogram, to plot these percentages or these ratios instead of these counts, now we would have a histogram that shows percentages instead of just raw numbers. Now to do that, we highlight our graph. And if you're on a Windows computer, then you right-click. If you're on a Mac, sorry I can't help you more, but some way there's a way to bring up this menu. And there's an option here to select data. And here we've got a window that tells Excel what we want it to graph. We want to use these bin names as the same things as they were before. And on this menu off to the left here, we're going to add one new column of information for it to graph. And the values that we want it to graph, delete that, are these decimal places right here. And we hit OK. So now we see that our graph down here has changed. We're graphing two different sets of numbers. The one called frequency is our blue counts. And this other one here that I haven't named yet, it's just called Series 2, is these orange percentages. And if we turn off this frequency tab, or that button, and then hit OK, Now we've lost the names of our x-axis here, but we can change that back. Oh, there. Did it change on its own? There we go. Okay. So now we have essentially the same graph, but on the y-axis we now have percentages instead of counts. And we can use graphs like this to ask questions like, what proportion of the data is between 2 and 5.99? And that would be the same as saying how many data points are between 2 and 5.99. And we can simply go up to our frequency table up here and say, well, there were 4 values between 2 and 3.99. There were another 5 values between 4 and 5.99. So there were a total of 4 plus 5 equals 9 between 2 and 5.99. Now if we want to do that with percentages, we could say, well, that's 9 out of 15, which would be the same as taking these two percentages and adding them two together. We can also do that with the graph. Say perhaps we don't have that table in front of us. The graph includes all the same information. The height of this first bar right here is give or take about 26 or 27, or 0.26 or 0.27, about 27%. And this next bar has a height of about 0.33. And if we add those two together, we see that the proportion of our data that is included in either this bar, or this bin, or this bin, is about 60% or so, about 64, 65, maybe 66%. It would be 60%. So that would be 9 out of 15. Those percentages or those proportions are areas of these graphs, and that's the link that we want between histograms and the PDFs for the normal distribution. Now if we wanted to represent this as a picture of a normal distribution, normal distributions are approximations, and the normal distribution that we want to use is the one that has the average that our column of graph has. So we can use the built-in Excel function average to calculate the sample mean, often called x bar, equal to 4.4. And we haven't done this yet in any of my videos, but the formula or the command in Excel for standard deviation is stdev. Open parentheses, highlight our data. And this is the sample standard deviation and not the population standard deviation. And our standard deviation is, we'll call it 2.4 with a little bit of rounding. And the symbol we usually use for that is the letter S. So if we were to draw a normal distribution with a mean of 4.4 and a standard deviation of 2.4, we should be able to calculate probabilities like the proportion of data that's between 2 and 5.99 or 2 and 6 as an area inside of that normal distribution function instead of inside of this histogram. So here is such a picture. And I've already drawn my nice little bell curve here. This would be the distribution of XXX. And technically we should label that. So the center of our distribution is 4.4. The standard deviation is 2.4, and I represent that as the width of this arrow here. And if you want to try to learn to draw these pictures to scale, there's a point somewhere right around here or so where it looks like the that upper line kind of changes its curvature, where in the top portion up here it looks like it's kind of curving down. And then somewhere right around here it turns into a straight line, and then after that it looks like it's turning up. The point where that curvature changes, if you've taken some calculus, you know that this is called a point of inflection. That's one standard deviation away from the mean. So learn to make your pictures to scale and label those one standard deviation points correctly. So my mean here, my center is 4.4. One standard deviation above that is 2.4 higher. That gets us to 6.8. If you want to go one standard deviation further, that would get you to be 9.2. And if you wanted to go down one standard deviation from the center, that gets you to 2.0. And one standard deviation further below that would be negative 0.4. Now, as I said earlier, we can use these pictures to represent things like the probability of a random value being between 2 and 5.99 or 2 and 6. And since I've drawn this picture to scale, I can very carefully put a line right around here and say that that represents 6.0. And just as we saw in the histogram, where an area represents the probability of getting certain values, this area right here represents the probability that a random value from this distribution with a mean of 4.4 and a standard deviation of 2.4 will be between 2.0 and 6.0. Now, later on in the chapter and in another video, I will show how to calculate those probabilities using the normal distribution table that is usually placed in the back of any statistics textbook.